And so, what about vector equation of a plane that is in another form? We have got r equals to a plus lambda b plus mu c. So r is again the position vector of any point on the plane, and hence it is just x, y, z. What about a? A is the position vector of a point on the plane, and it must be given to you. Lambda and mu are parameters, and please note that it is not necessary for lambda and mu to take the same value. It can be any values the two could take. It could be a positive, a zero, or a negative value, right? And what about b and c? B and c are the direction vector that is parallel to the plane. But note this, b and c are not parallel to each other then. Okay, so how do I check that if b and c are parallel to each other? Okay, you must have checked that b and c cannot be written in such a form. K being any constant lah. Okay, so if I were to give you 1, 2, 3 to be your b, let's just say, okay, or maybe, okay, not 1, 2, 3, maybe 2, 1, 5 to be your b, okay, and your c is 0, negative 1, and 1, and you do know that there is no way I can form such an equation, yeah, b equals to k c, and that is when you say they are not parallel to each other. Okay, right? So example given, okay, r is equals to 1, 2, 3, that is your a, plus lambda, b is 2, 1, 5, and plus mu, 0, negative 1, and 1. Okay, this form we hardly use. It is more of the first form that we use for vector equation of a what do I call? A plane. All right. So what then about vector equation of a sphere? Vector equation of a sphere is of this form. It is the modulus of r minus c equals to a. So let me explain to you the meaning of modulus of r minus c again. Modulus of r minus c simply means distance between any point, your r, okay, distance between r and c, and it means to say it is the distance between any point on the circumference of the sphere to the center of the sphere, right? And since it is the distance between a point that is on the circumference of the sphere and also the center, we are simply telling you the radius, okay? Hence, modulus of r minus c equals to a, and a for this case is a radius, okay? So example given to you, okay, let's just say center of the sphere was 1, 2, and negative 4. So I'm going to just plug it here, and the radius of the sphere was 5. Hence, this is the equation that you got to write as the vector equation of a sphere. Now, how then can I convert this into a Cartesian equation of a sphere? Again, this sphere has got no parametric equation because there is no parameter in the vector equation. There is only Cartesian equation, and it is to be written in such a form. Yeah, just like how you have been writing equation for a circle, but with spheres we have got 3 dimensions, right? So it is x minus 1 in bracket square, y minus 2 in bracket square, sec minus negative 4, hence sec plus 4 in bracket square equals to 5 squared. This is the part that you got to be mindful of. Yeah, we give you the radius, and this should be radius squared. Alright, yeah, and what is next that I'm going to talk to you? Okay, this is the last part of this video. Dot product and scalar product. Okay, sorry, dot product or scalar product and vector product or cross product. Yeah, just like what I've told you, like, you know, a few times or quite a bit of times in class. Okay, dot product or scalar product is used, okay, to look for a scalar. Right, just like what we have done earlier with the multiplication of dot product of 2 vectors, we are going to get a scalar. So what is the use of dot product or scalar product? It is to find angle between vectors. So let's just say I've given to you 2 vectors, vector A and B. So what is the dot product? A dot B. Okay, mind this one, A dot B. It's equivalent to the magnitude of A times the magnitude of B cos theta. Theta is simply the angle between the 2 vectors. Okay, so this is mainly used to find angle between 2 vectors. What then about vector product or cross product? Cross product means you're going to see still a multiplication, but this time around a cross. Yeah. So what is this for? What is vector product for? What is a cross product for? It is to find the normal vector to A and B. Okay, so it means to say if I were to have A and B to be here, the normal vector that I'll find for A and B would be like that. Now, because both A and B are on the board, so to be 90 degrees to both A and B, it must be something protruding in such a way. Alright, so how then do I do cross product? Okay, I'm going to put 1, 2, 3 to give my A, and B would be 0, 1, 1. How do I perform cross product? First component, I'm going to cover the first column, and I have 2 to multiply by 1, minus by 1 multiplied by 3, and that would give me negative 1. And to come up with the second component, note that there is already a negative and there must be a negative there. You're going to cover the second column, and this time around it is 1 times 1 minus 0 times 3, hence 1. And with the original negative there, it is negative 1. Alright? And what about for the third component? You're going to cover in such a way, and that is when you will perform 1 times 1 minus by 0 times 2, and hence it is 1. Okay? So, the normal vector that is perpendicular to both A and B would be negative 1, and 1. Alright? So how do you check whether or not you have gotten the right answer? Like, how do you know this is the right answer? So let me just let W to be negative 1, and 1, and note that W is perpendicular to both A and B. So how do I know whether I got the right answer? I'm going to go. Okay, checking like that wouldn't give you more marks, but it is to make sure that you have gotten the right answer. So W dot A would be negative 1, 1, dot 1, 2, 3. If you were to get a 0, it means to say you have gotten the right answer, because when you have two vectors to dot product, you get a 0, it means to say the two vectors are perpendicular to each other, right? So I'm going to do like further checking. W dot B, and it is negative 1, 1, dot 0, 1, 1. You should again be getting a 0. If it is not a 0, do check your answer. Okay?